Hello everyone, I am Said. Welcome to my YouTube channel. Let's start with chapter 3, which is related to data cleaning. I already explained different data types in chapter 1, and in chapter 2, I represent how to perform filtering on different data types. So I recommend you to read those chapters to understand the concept of this chapter easily. So let's start with data cleaning. Before diving into any data analysis, you need to ensure that the data set is clean enough and there is no pollution in data. So in this chapter, I walk you through the process of cleaning and explain you how to get rid of pollution in data. So that's why I entitled this chapter as data cleaning. First, I explain some simple functions that help you for data cleaning. I will cover those functions in slide 2 and slide 3. In slide 2, I will cover functions related to a data frame, and in slide 3, I will cover some functions related to a specific column. Then I will identify various types of pollution that you may encounter during your data analysis and explain how to effectively clean each of these pollutions. So the type of pollutions are having null values, having duplications, having extreme values in a data frame, bad formatting, extra spaces, missing leading zeros, very old data, and missing data. And similar to other chapters, we have a Python script for chapter 3 where I illustrate the concept of this chapter through practical examples. In the first cell, I import some libraries, as I explained in previous scripts. In the second cell, I will read some tabs from an Excel file, input data. I already post this Excel file in my channel. So here I read different tabs of this Excel file and I store them in different data frame, as you see. And we read one AccessInput, which is one access database. And I focus on suppliers table in this access database and I store it in suppliers data frame. Now to explain the simple functions on the data frame, I focus on customer order lines 2023. I mean this data frame, and this data frame actually is this data frame, and it is tab customer orders 2023, which is this tab in Excel input. And this tab shows all customer order lines of 2023. For example, this row shows this retailer number and bought this item at this date. We could meet demand, and the size of demand is 249 pieces. So here I focus on this data frame, and I already print this data frame here. As you see, this data frame has 2000 rows and 6 columns. And as I explained, the range of indexes in a data frame starts from 0. So in this case, we have 0, 1, 2 until 1999. And it means we have 2000 rows. And one note here, whenever I say rows or records, I mean the same. And whenever I say columns or fields, I mean the same. So let's start with simple functions. The first function is .head function. By using this function, we can show the first n rows of a data frame. So in this case, we have data frame name .head 7, and it means show me the first 7 rows of a data frame. A similar function, it's .tail function. By using this function, we can see the last rows of a data frame. So in this case, we have data frame name .tail 7, and it means show me the last 7 rows of a data frame. The next function is .sample. By this function, we can generate n random rows from a data frame. So in this case, we have data frame name .sample 5, and it means generate for me 5 random rows from customer order lines of 2023. And here you can see 5 sample rows. And if I generate it again, you can see another 5 rows generated here. The next function is .column. I use this function a lot. Using this function, you can see the column names in a data frame. So here you can see the column names. .shape shows the number of rows and number of columns in a data frame. .shape 0 shows the number of rows. .shape 1 shows the number of columns. And .info function shows some general information related to a data frame, including column name, number of non-null values, and data type. In this case, we have order ID as a first column and 2000 non-null values in that column. By non-null values, I mean the number of rows that are filled, the number of rows that are not empty. So the type of data in that column is integer. We have retailer number again, 2000 non-null values, integer. Item number, 2000 non-null values, again integer. Order date, 2000 non-null value, and type of data is date. meet or missed 1998 non-null values, and it means we have 2 empty rows, and type of data is object. Sales quantity, again 1998 non-null values, and it means again we have 2 empty rows, and type of data is float. And here you can see a summary. It means we have 1 column with type of date, and it is order date. We have 1 column with type of float, which is sales quantity. We have 3 columns with type of integer, which are the first 3 columns, and we have 1 column with type of object, which is meet or missed. And here you can see the size of data frame. I mean, how much that data frame takes from your memory. Here's the total number of integers in the data frame. So we have 2000 integers or 2000 rows in the data frame. The range of indexes is from 0 until 1999. So as you see here, we can see some general information related to customer order lines 2023 data frame. And the next function is .copy. From .copy, we can make a copy from a data frame and store it to another data frame. So here I make a copy from a main data frame and I store it to another data frame. If I print the new data frame, you see the same as this data frame. So here is the summary of different functions on a data frame. I already provide you with some examples. Here you can see the syntaxing. As you understand in the syntaxing, I need to replace df with the name of data frame in your analysis. So let's go to the next topic, which is related to simple mathematical function on columns. In this topic, I want to focus on a specific column in a data frame and get some insight about that column. Insight like minimum value, maximum value, average value, and some metric on a specific column. So again, I explained this topic with examples, and then I will back and summarize the syntaxing. Let's start with some examples. In this example, I want to focus on customer order lines 2023. I mean, this data frame in our Excel input, and I want to define some metrics. In this data frame, I want to focus on column sales quantity, and I want to find the minimum value in this column. So by using data frame name, column name, and .min, I can find the minimum value of sales quantity, which is in this case 10. And if I go to data frame, as you see, the minimum value is 10. Similarly, I can find the maximum value. So data frame name, column name .max shows the maximum value in sales quantity. And again, in this tab, I can see the maximum value is 500. We can find the average of sales quantity. .min shows the average, which is 253. And if I select the whole column, I can see the average is 253, which is the same as this value. .std shows the standard deviation of sales quantity. .var shows the variance of sales quantity, and .sum shows the sum of all values in sales quantity. Again, if I select this column, you can see the sum is 506426, which is the same as this value. Okay, let me explain something here. The note that I want to mention here is that whenever you use column name, I mean here you have single quotation. It doesn't matter if you use single quotation or double quotation. Okay, both give the same result. So in any Python script, in any line of your Python script, when you have single quotation, you can also use double quotation. Okay, it doesn't matter. The only case that single quotation and double quotation matters is when you write SQL in Python. Okay, and I covered in chapter 90. So before chapter 90, you can use single quotation and double quotation interchangeably. So you can use also here single quotation or double quotation, here also the same. So let's try this case. So here you can say find the average of sales quantity. You can here use double quotation and you see this. And the other note is that whenever your column name doesn't have any space, you can use without any bracket and just use dot. Okay, so here you can say data frame name, column name, and .min. So you can use this approach when your column name doesn't have any space. If your column name has a space, for example, like this, you have to use it bracket and put it in quotation. So if you have space, then you receive an error. Okay, that's why maybe I emphasize several times in chapter 1 that never ever use a space whenever you want to define a column name or a data frame. Okay. And the next function is IDX max function. This function actually returns the index of first row where the sales quantity takes the maximum value. Let's see previous example where sales quantity takes a maximum value of 500. Here I print two rows where the sales quantity is 500. And as you see, the index of first row where sales quantity is 500 is 1141. And it is the same as the value which is returned by this function. We have IDX function, which is similar to previous function. By using IDX function, we can find the index of first row where the sales quantity takes the minimum value. Again, in previous example, we had sales quantity with minimum value of 10. And here you can see rows where sales quantity is 10. And index of first row where sales quantity is 10 is 531, which is the same as the value which is returned by IDX function. Okay. The next function is .describe function. By using this function, we can get some metric together. For example, one of them is a count, which shows the number of non-null values in sales quantity column. Mean is average of sales quantity. STD is standard deviation of sales quantity. Mean minimum value of sales quantity. Max is the maximum value of sales quantity. And here you can see some quantiles. And what those quantiles mean, for example, 25% quantile is 131, and it means 25% of data in sales quantity is less than 131. We have 50% quantile, which is 249, and it means half of data in sales quantity is less than 249. We have 75% quantile, which is 379, and it means 75% of the data in sales quantity less than 379. So as you see, that the describe function shows some metric here. Please note that here we can see the minimum value, maximum value, and average of sales quantity. And these quantities are the same as these quantity that we apply separately. Okay. And if you apply .describe function on a data frame itself, you can see those metrics over numerical columns. So here we have 4 numerical columns in customer order line 2023, and here you can see those metrics. So for example, the standard deviation of item number is this value, the maximum value of retailer number is this one, and the average of sales quantity is this one. Okay. And one note here, we can apply min and max function on column with type of date. So in customer order line, we have order date, which is in type of date, and .min shows the minimum date in order date, and .max shows the maximum date in order date. So as you see, the minimum date is 1st of January, and maximum date is 31st of December. And if you go to customer order lines and order date, we see the first date is 1st of January, and the last date is 31st of December. So as you see, these functions work also properly. Let's focus on the next data frame. I want to explain some functions by using item data frame. I mean, I want to focus on this tab in Excel input and explain some functions over this data frame. I already printed data frame here to make sure that data frame exists. Now I want to focus on item data frame and explain some new functions. First, I start with .unique. Using .unique function, we can see the unique values inside of a column. So in this case, I want to focus on item data frame, and I want to focus on column category, and I want to see what is the unique values inside of that column. As you see, cleaning product, vegetable, foods, furniture, and bread are unique values inside of category column. And if I go to Excel file and click on category, you can see these unique values, which are the same as these values. Okay. By using an unique function, we can see the number of unique values. As you see, we have 1, 2, 3, 4, 5 unique values. And here we can see 5 as a number of unique values. Value count shows the number of rows that include that unique value. So in this case, we have 34 rows that include furniture, 26 rows that include cleaning products, and 70 rows that include vegetables, and etc. So if I go to category and filter on, for example, foods, you can see we have 30 rows. Here you can see the number of rows that include foods. And if I go there, you can see 30 rows include foods. And by using ascending to in parentheses, you can see that order from lowest to highest. You can see here from highest to lowest, I mean 34, 26, etc. And you can see from lowest to highest. And if you want to see the number of rows that include a specific category, you need to put that category in bracket. So in this case, I want to see the number of rows in column category that include vegetables. Then I put vegetables in bracket, and I see the number of rows in category column that include vegetables, which is in this case 70 rows. Okay, if I go to category and I filter on vegetables, you can see 70 rows, and it's the same as this value. And in next example, I want to see unique values in demand class column in item data frame. And I want to see the number of rows that include each demand class. If I go to demand class column, as you see, we have 3 unique values. And here you can see the number of rows that include those unique values. So we have 40 rows that include A, 36 rows that include C, and 27 rows that include B. If I, for example, filter here on value of B, you can see 27 rows include B, and here you can see 27 rows include B. And again, if you want to see the number of rows for a specific category, here you can put the specific category. Here I want to see the number of rows in the demand class column that includes category C, and here you can see the number of rows. So 36 rows include C. And as you see, by filtering on C, you can see 36 rows include category C, which is the same as this value. So here you can see the summary of different mathematical functions on columns. As we explained, .min shows the minimum value of the column, .max maximum value, .min average value of the column, .std standard deviation of values in the column, .sum summation of all values inside of the column, .describe shows some metrics like mean, max, standard deviation, and some quantiles. .unique shows the unique values inside of the column, and nunique shows the number of those unique values. And by using .value count, you can see the number of rows that include each of those unique values. And by value count in bracket value, you can see the number of rows that include that specific value in column name. Okay. So I explained some different functions on a data frame, and here I explain some different functions on a column. Then I use these concepts together with concepts in chapter 1 and chapter 2 to explain you how to use those concepts to get rid of pollution in your data set. Now let's focus on first type of pollution, which is null values. As I explained in previous chapters, the null values in columns with type string, floats, or integers are shown as NaN, and it means not a number. And null values in columns with type of date are shown as NaT, and it means not a time. Now, the question is that how to handle rows with null values. We have 3 options. First, do not do anything and leave empty rows as it is because they don't affect our analysis. Second, eliminate the rows with null values. And third, replace null values with some meaningful values. Let's see some examples again in our Python script, which is related to our case study, and see how I apply these 3 options. The first step for handling null values is to understand which columns have null values and how many rows are empty in those columns. To do so, we can apply .info function. So in this case, by applying .info function on item data frame, we can see this data frame has 103 rows or non-null values. So any column that has non-null values less than 103 contains empty rows. So in this case, we have column on hand, which has 96 non-null values, and it means we have 7 empty rows in that column. And we have column size that has 93 non-null values, and it means that column has 10 empty rows. So the question is how to handle these empty rows in these 2 columns. As I explained, we have 3 options for handling null values. Let's see when we can use option 1, which is do nothing. Let's suppose that I want to do some analysis related to lifetime or demand class of items. I mean, if I go to tab item, here we have lifetime, and demand class. Since this analysis is not related to size or on hand of items, so I can leave empty rows as it is and I do my analysis, because having empty rows in on hand and size will not affect the result of my analysis. But if I want to do some analysis related to warehouse capacity, then the size of item matters and I need to think how to handle items with null size. Or if I want to do some analysis related to inventory on hand, for example, to see total stock in warehouses, then on hand stock is important and we should have correct data and somehow handle empty rows in column on hand. Next, let's see when we can use option 2, which is eliminating null values. Suppose that you want to do some analysis related to on hand inventory. I want to focus on column E, and those empty rows in column E may cause some misleading results. For example, you want to see how many items are out of stock in your portfolio. Then you have doubt if you need to report those items as a list of items which are out of stock. In such situation, we prefer to eliminate empty rows to prevent any wrong output in our analysis. So if I filter on blank in this column, you can see I have 7 blank value. 7 null values. As you see in on hand, here we have 7 null values. Now the question is, what should I do with those null values? And in this case, the preference is to eliminate those null values. As you see in item data frame, and as explained in chapter 2, you can eliminate null values with this filtering. So I say in this data frame, look at on hand and just report for me the one that is not null. Then in item data frame 1, you see all on hand values are filled. As you see in this data frame, we have 96 rows. It means those 7 empty rows in on hand column are eliminated. Then we can do our analysis in item data frame number 1. And finally, let's see when we can use option 3, which is replacing null values with some meaningful data. Let's see first example where I want to replace null values in column on hand with 0. In this case, for example, I communicate with our inventory team and they ask me to set 0 for those null values, since they believe that they sometimes put empty instead of 0. So it's the way to fill null values in column on hand with 0. In this case, you need to use fill_NA function. By using fill_NA function, you can replace null values with anything. You can replace null values with numbers, string, or dates. In this case, we can fill null values with 0. So here we can say in item data frame, look at on hand column and find any null values in column on hand and replace them with 0. Okay, so this fill_NA can be one string, can be date, or even can be one empty rows like this. So here I just want to replace them with 0. Let's see another example, and let's suppose that I want to calculate the total capacity occupied in our warehouse. So in this case, we need to know the size of all items. Any missing values in size of an item can result in inaccurate analysis. So the smart way here is to replace the null values by looking the average size of item in the same category. For example, if I want to focus on an item that has empty value and that item has category food, then we can take the average size of all items in category food and then replace that value with missing size values. For example, let's go to tab items in our input file. If I filter here on category, for example, bread, I see there's one null value and all of these items have the category of bread. So if I take the average of this column, the average of column is 0.651, then I can replace this null value with 0.651. The average of these existing values is 0.651, then I can replace this null value with 0.651. If I select another category, for example, furniture, and the average of this column is 0.637, then I can replace this value, and this value with 0.637. Please note that Excel look at the field values to find this average value. Okay. Another case, for example, I can focus on cleaning products. So the average of cleaning products for existing values is 0.558. Then I can replace this null value and this null value with 0.558. Okay. So it was the best option to do. But in this example that I provide here, I just replace null values with average of size in all rows. I mean, I did not focus on average per category. In next chapter where I explain more advanced topics, you will be able to do this exercise based on average per category. Now, what I did, I just take the average of size in item data frame and I store that average in variable and I call it size mean. Then I say in item data frame, look at the column size and find any null values and replace those null values with size mean. And size mean is calculated in this step, which is simply the average of column size. I mean, in this tab, I look at the average of size, and average of size for all rows is 5917, and I replace all of these null values, I mean the first, fourth one, and this one with this value. Just remember this value, as you see the first and fourth row are empty, and that value is appeared here, the first row and fourth. Okay, so it's also another method to fill null values. Okay, now let's summarize how to fill null values in a data frame. As I explained, we can use fill_NA function. By using fill_NA function, actually we can find the null values in a column name in a data frame, fill those NA values with variable x1, and then update the column name based on those field values. So please note that in Python, when we have a assignment sign, this equality, we call it assignment sign or equal sign. Whenever you see equal sign in Python, it means read the code from right, do some calculation in the right, and put the result to the left. So in this case, it means fill null values with x1 and then update column name in the left. So it's a general syntax. Let's see some examples. In the first example, I want to focus on data frame df with order quantity, and I want to fill null values with 0. It means in data frame df, if there is any row with null value in order quantity, we replace those null values with 0 and update the order quantity. In the second example, I want to focus again in data frame df, and I want to focus on column supplier name, and I want to fill null values with unknown. I mean, I want to fill null values with a string, and that string is unknown. Please note that when I use quotation or double quotation in Python, I mean a string. So in this case, we focus on supplier name column, and if there is any rows in supplier name column with null values, we replace those null values with unknown. In the third example, I want to focus again in data frame df with column name, and I want to fill null values with a variable, where that variable can be calculated somewhere in the code. For instance, in the example that I already provided you in our Python script, in some line of the code, I find the average of size with existing data, and then I fill null values with that average size. So it's the way to fill null values on a specific column in a data frame. So until now, I explained you how to handle null values in a data set. I use 3 approaches, and I also provide you with some examples. Next, I will focus on the second type of pollution, which is duplication. First, we see what is duplication in a data set. Then I explain you how to find them and how to drop them. Again, let me explain it through examples in our Python script. This time, I want to focus on purchase order lines 2023. I already printed the data frame here. This data frame actually is purchase order lines 2023 in Excel file. This data frame actually shows the orders that we bought from our suppliers. For example, this line shows we bought this item from this supplier. That's the order date. That's the promised delivery date. The order is dispatched. The lead time of the order is 6 weeks. That's the arrive date. And the size of order is 967 pieces. So you can see this data frame here. To drop duplication in a data frame, we need to follow 2 steps. The first step is to find the primary key. The primary key is a column or combination of columns that uniquely identify records in a data frame. To find the primary key in a data frame, you should have a comprehensive knowledge about the content of data in a data frame. Let me provide you with some examples to better understand the concept of the primary key. For this purpose, I want to use our input data and define the primary key for each table. Let's just start with suppliers table. This table actually shows the supplier's information like supplier code, supplier name, and so on. We assign a unique supplier code to each supplier. On the other hand, each record of this table shows information of a single supplier. So we should have only one row per supplier code, and it means supplier code is the primary key, and there should not be any duplication in supplier code column. So column D is the primary key. To find duplication in Excel, you can focus on the column, click on the column, go home and conditional formatting and duplicated values, press OK. And if there is any duplication, those duplication are marked with the red color. So there is no duplication here, so you cannot see any red colors here. So let's go to another tab, which is warehouses, and it shows our warehouse information. As you know, each warehouse has a specific name. And since each record shows information related to a single warehouse, we should have only one row per warehouse name. And as I explained in chapter 1, in our case study, we have 3 warehouses. And here we assign one row per warehouse. So in this table, the warehouse name is the primary key. And as you see, there is no duplication in column warehouse name. Okay, 3 warehouses, 3 records with unique warehouse name. Next, let's focus on retailers table. This table actually shows information related to our retailers. Again, we assign a unique retailer number to each retailer. On the other hand, each record of this table shows information of a single retailer. So we should have only one row per retailer number. And it means retailer number is the primary key. Let's check if there is any duplication retailer number. We click on column A, conditional formatting. Okay, here you see some rows appears as a red color. And so here we can see this retailer number 00819 is repeated 3 times. I mean here and here. So we need to keep one of these records and eliminate the other 2 records. Okay. 00820 also repeated twice. So we need to keep one of them, this one, and for example, eliminate this one. And we have 10112 repeated twice. We need to keep one of them and eliminate the other one. So as you see, 3 retailer numbers are duplicated. Let's cancel the next table, which is items table. In this table, we store information related to items like item number, item name, the warehouse where the item is located, the on-hand inventory, weekly demand, and so on. Here, since we can store a single item in 3 warehouses, for each item, we can have maximum 3 rows. For example, if we cancel item number 5033, as you can see, for this item, we have 2 rows. We store this item in taxes, and we have 86 pieces. We store the same item in London, and we have 40 pieces. So we cannot say item number here is duplicated. No. Here, the combination of item number and warehouse is the primary key. And the combination of item number and warehouse should be unique. And the question is how to find duplication. Here you cannot say I can click on column A and also column C. Then I do conditional formatting and find duplication. No, it's not correct. So here I want to explain you how to find duplication. To find duplication in cases where we have multiple columns as a primary key, you need to first join those columns. So here I will join first item number with warehouse, and you can use AND operation to join them. Then I make a primary key. Then I will find duplication in this column. So as you see, I have some duplication here. So this item number in taxes has duplication. See, this row is the same as this row, so it's duplication. This row is the same as this row, so it's duplication. And this row is the same as this row, and it is duplication. So as you see here, we have 3 duplications. Okay, let's focus on the next table, which is purchase order lines 2023. This table actually shows the order that we bought from our supplier. For example, this line shows we bought this item from this supplier at this date. That's the promised delivery date. That's the status of the order, lead time, the arrive date, and the size of the order. In this table, we use purchase ID to uniquely identify each record in this table. So we can say purchase ID is the primary key. Here, maybe somebody says the combination of item number and supplier code can be the primary key. But it's not correct because we can order the same item with the same supplier, but on different order date. For example, if we can insert this item number that we bought from this supplier code, then as you see, we order the same item with same supplier, but on different order date. So we cannot say this is duplication. These two are two distinct records. We bought this item from this supplier on this date. We bought the same item with the same supplier but on different date. And may somebody says, okay, then the combination of item number, supplier code, and order date is the primary key. But again, it's not correct because it's possible that we order the same item with the same supplier on the same date, but with different order quantity. And then may somebody says, okay, then the combination of item number, supplier code, order, and order quantity is primary key. Yes, that might be correct, but it makes the definition of primary key a bit complicated. So I prefer to define a purchase ID as a single column to uniquely identify record in this table. So each purchase order line has a unique purchase ID. So purchase ID is the primary key. To find duplication, we can click on column A, home, conditional formatting, duplicated values, and then we can check if there is any duplication. Yes. So as you see, 292 is repeated 2 times, 988 4 times, 483 2 times. So 988 is duplicated. Please note that by duplication, I don't mean necessarily 2 records. So if one record is repeated more than once, so we call it duplication. Okay, let's focus on the next table, which is customer order lines 2022. Here again, I define an order ID, and that order ID uniquely identifies each record. Each customer order line has a unique ID. So order ID is the primary key in this table. And similarly, we have customer order lines for 2023 is the same table, but for year 2023. And again, order ID is the primary key for this table. The next table is inventory projection. In this table, actually, we monitor the inventory of different categories over time. I mean, here we have 4 categories, and we record the total on hand of these 4 categories over time. So we can say the combination of date and category is the primary key. We cannot say date is the primary key because for a single date, for example, for a specific date, let's select 4th of February, you can see 4 categories are here. So date is not primary key because if I select date as a primary key here, I have 4 duplication and it's not true. So the combination of date and category is the primary key. And let's cancel the last table, which is date conversion. As I explained in this table, I find the corresponding week, corresponding period, and corresponding month for a specific date in the calendar. So for each date, we have a single record. So we can focus on column A, click on it. When filter by colors is inactive, it means there is no duplication. Okay. So we define primary key for each table. So as you see, having a comprehensive knowledge about each table is very important to define the primary key. So let's get back to our Python script where I can explain you how to drop duplication in Python. As I explained, to drop duplication, you need to follow 2 steps. The first step is to find the primary key in a data frame. I already explained you what is primary key, and I also specify primary key for each tab in our input data. Now I want to focus on purchase order lines of 2023. I mean this tab in our input data that shows purchase order lines in 2023. Now I want to find duplication in Python and explain you how to drop duplications. The first step is to check, is there any duplication on primary key? As I explained previously, you can use value count function to find the number of record per purchase ID. As you can see, the purchase ID 988 is repeated in 4 rows, purchase ID 292 is repeated in 2 rows, and purchase ID 483 is repeated in 2 rows. And the rest of purchase ID is repeated only once. So we have duplication for these 3 purchase ID. We already see it also in purchase ID in Excel file. Here, if I filter on duplication, you can see 292, 483, and 988 are 3 purchase ID with duplications. So it's the way to find duplication in the primary key. Now the second step is to drop those duplications. We can use drop duplication function in Python to drop duplications. Here you can see the syntaxing. You can write the name of data frame, drop duplications. In subset, you can define the primary key. In this case, primary key is purchase ID. And keep function helps you to decide on rows that we need to keep and the rows that we need to eliminate. For example, keep first means we need to keep the first row where duplication appears and eliminate the rest. For example, in Excel file, keep first means if we have duplication in 292, so here we have 292, and here we have also 292. I mean, in rows 293 and row 1009, we have 292 as a purchase ID. Keep first means keep the first one, which is this row, and eliminate the rest, which is this row. And keep first for 483 means keep this one and eliminate this one. And keep first for 988 means keep this one and eliminate the rest, which is this, this, and this. We have also keep last in Python instead of keep first, and keep last means, for example, in this case, again, we have 292, and here we have 292. Keep last means keep this one, I mean the one in row 1009, and eliminate this one. And keep last for 483 means eliminate this one and keep this one. And keep last for 988 means eliminate this, eliminate this, eliminate this, and keep this one. So somebody may ask, what's the application of keep first and keep last? So I would say using keep first or keep last doesn't matter when the duplicated rows are exactly the same. I mean, the value of all columns are the same. Then using keep first or keep last doesn't matter. But if you want to drop duplication based on a condition on a column in the data frame, then using keep first or keep last matters. Let me explain you what I mean in our data frame. Let's go to our purchase order lines. Here we have duplication in purchase ID 292 in this row and this row. As you can see, these two rows are exactly the same. Let me mark them with yellow. All values in all columns are the same. So in this case, doesn't matter to use keep first or keep last. If I use keep first, I will keep the first row and I will eliminate the last one, I mean the second one. And if I use keep last, I will keep the second one and eliminate the first one. In both cases, I will get the same result. But let's cancel the other case where we have duplication for ID 988. I mean, we have 4 rows with ID 988. Let me again mark them with yellow. These 4 rows have ID of 988. As you can see, these rows have different order date. And maybe somebody says, based on my experience, we need to keep the row with last order date and eliminate the rest. I mean, we keep the row with newest order date and eliminate the rows with oldest order date. So in this case, we want to keep this record because the order date is the earliest, 24th of December, and the rest is before 24th of December. So we are going to keep this row, which has the newest order date, and eliminate the rest. So in such a situation, when you want to drop duplication based on a condition on another column in a data frame, it's better to first sort the data frame based on that column and then drop the duplications. And in those cases, using keep first and keep last matters. I mean, in this case, you need to first sort this data frame based on order date. As you see, we have order date from newest to oldest. So in this case, we need to keep the first row and eliminate the others. So here we can use keep first to eliminate duplication. Or you can do it another way around. You can sort it from oldest and newest. Then in this case, you need to use keep last in order to eliminate these 3 rows and keep the last row. So as you see, whenever I want to drop duplication based on conditions on a column in a data frame, we need to do some sorting on that column and then drop duplication based on using keep first or keep last. So here I provide you one example and I explain you how to drop duplication based on condition on a column in a data frame. Here I drop duplication in purchase ID column based on condition on order date. We keep the row with the latest order date and we eliminate the rest. But how to sort a data frame based on a column, in this case, how to sort a data frame based on order date, I explain it in chapter 5, how to do sorting. So whenever you want to drop duplication based on condition, you need to first do sorting and you need to read chapter 5. In chapter 5, I explain you how to sort a data frame based on column or multiple columns. Okay, so again, let's back to our Python script. Whenever you want to drop duplication, and it doesn't matter which record we need to keep and which record we need to eliminate, you can use either keep first or keep last. Or whenever all values in all columns for duplicated records are the same, then it doesn't matter to use keep first or keep last. But whenever you want to drop duplications based on condition on other column in a data frame, you need to first do some sorting on other columns and drop duplication by using keep first or keep last. So in Python, there is no functionality to say drop duplication based on these conditions. For example, we cannot say drop duplication whenever the order date is the earliest. Or for example, we cannot say drop duplication when the order quantity is the largest. Or we cannot say drop duplication when lead time is the lowest. Or we cannot say drop duplication when a status is dispatched. So whenever we want to drop duplication based on column, we need to think of sorting on those columns and then drop duplication. Now let's see how we can apply these two cases in our Python script. In the first case, I suppose that it doesn't matter to keep first or keep last. It means I just want to keep one of the duplicated rows and eliminate the rest of duplicated rows. So I just apply drop duplication on a data frame on primary key, and I can use keep first or keep last. Here I apply that drop duplication function and purchase order 23 data frame on primary key purchase ID, and I keep first. And I store the resulting data frame to a new data frame, and I call it purchase order 23 data frame 1. So here, please note that purchase order 23 data frame has still duplication, but purchase order data frame 1 doesn't have any duplication. But if I use the same name here, I mean, if I use purchase order 23 data frame, then it means I drop duplication in purchase order 23 data frame and I store to the same data frame. And it means from this line onward, purchase order 23 data frame doesn't have any duplication. But in this case, I want to store to a new data frame. And now if I apply value count function on a new data frame, as you see in purchase ID, there is no duplication. However, in purchase order DF, as you see here, we had 3 purchase ID that are repeated more than once, and there were duplications. So here, if I print a data frame 1, as you see, the number of rows is reduced by 5. I mean, here we have 1005 rows. However, here I have 1010 rows. So 5 rows are eliminated. It means 3 rows from here, 1 row from here, and 1 row from here. So in total, 5 rows are eliminated. So the new data frame, we have 5 rows less. Okay, let's consider the second case. In the second case, I want to drop duplication on primary key again, but I want to keep the rows with earliest order date. For example, consider purchase ID 988, where we have 4 rows with purchase ID 988. It means there is duplication. As you see, order date for these 4 rows are different. We have 11th of December, 14th of December, 20th of December, and 24th of December. In this case, I want to keep the row with earliest order date. I mean, I want to keep the row with 24th of December as order date and eliminate the rest. So in this case, when I want to drop duplication based on condition on another column, I need to first think of sorting and then drop duplication. As you see, in the first step, I sort the data frame based on order date by using sort value function, and I use ascending through, and it means in purchase order 23 data frame, sort the data frame based on column order date and sort them from oldest to newest. Here I filter on purchase ID 988, where we have duplication, and as you see, order date is sort from oldest to newest. Now in the second step here, I want to drop duplication on purchase ID and keep last. Since in the first step, I sort the data frame based on order date, keep last means keep the row with the earliest order date and eliminate the rest. And in this case means keep the row with order date of 24th of December and eliminate the rows that has order date less than 24th of December. I apply function in cell 55 and I store the resulting data frame to a new data frame and I call it purchase order 23 data frame 2. And if I filter on purchase ID 988, as you see now, we have only 1 row with purchase ID 988 and order date is the earliest, which is 24th of December. And the other 3 rows with order date less than 24th of December are eliminated. So it's the way to drop duplication based on condition on another column. As you see, the first step, I sort the data frame based on the column that I want to condition on. And in the next step, I drop duplication on primary key. Let's consider another example when I want to focus on item data frame. As I explained previously, in this data frame, the combination of item number and warehouse is the primary key. It means the combination of item number and warehouse must be unique. In this case, again, we use drop duplicate function. And as you see in subset, we specify the column considered as a primary key. So item number and warehouse are columns that are considered as a primary key. And in this case, since the all values for all duplicated rows are the same, it doesn't matter to use keep first or keep last. And in this case, I use keep first. I drop duplication in item data frame and I store the resulting data frame to the same data frame. And it means from this line onward, there is no duplication item data frame. So let's go to our slide and see what's the syntaxing for dropping duplication. As I explained, a primary key is the column or combination of columns that contain values that uniquely identify each record in a data frame. And it means the primary key must be repeated once. And here you can see the general format for dropping duplication. As you see, I use drop duplicates function, and in subset, I define the primary keys. And I use keep first to keep the first duplicated rows and eliminate the rest. And I use keep last to keep the last duplicated rows and eliminate the rest. I have also two notes here. The first note says, in subset, you need to mention the primary keys. I mean, the combination of columns that build our primary key. And in note 2, I address the case that you want to drop duplication by condition on another column. And I explain when you want to drop duplication based on another column, you need to do first sorting and then drop duplication. I already provide you with some examples in our Python script. Now we can go to the third type of pollution, which is extreme values. In the third type of pollution, we want to address extreme values in a dataset. And whenever I say extreme values, outliers, bias data, or anomaly, I mean the same. Outliers or anomalies are data points in a dataset that have abnormal distance from other values. And it means they are data points that have a strange pattern, and they are not similar to other data points in a dataset. To handle outliers in a dataset, we have two approaches. One approach is to eliminate them, and another approach is to replace them with some meaningful data. Let's again go to our Python script and see some examples. In example 1, I want to focus on purchase order 2023 data frame, and I want to focus on column lead time, and I want to check if there is any outlier in this column. In this case, for instance, based on my knowledge, or by asking some expert people in our team, we can conclude that any lead time that exceeds from 12 weeks is an outlier in our data. So in this case, if I filter on lead times greater than or equal to 12, as you see, we have two rows with lead time of greater than 12. In the first row, we have lead time of 139, and in the second line, we have lead time of 18. So these two records are outlier in our data, because having lead time of greater than or equal to 12 is unrealistic. And the reason for having these outliers can be human error or system transaction error. Sometimes records in a table are entered manually by some operators, and in this case, the operator may enter the numbers by mistake. So in this way, we detect the outlier, and somehow we need to eliminate them from the data frame. And in this case, it's very easy to eliminate the outliers. As you see in cell 59, I just filter on lead time less than 12, and I store the resulting data frame to the same data frame. And it means in purchase order 23 data frame, there is no lead time greater than or equal to 12. So by this filtering, I eliminate the outliers. Let's consider another example. In this example, I want to focus on order quantity column in purchase order 23 data frame, and I want to use another approach to detect outliers and eliminate them. This approach is actually one of the well-known methods for outlier detection. In this approach, we define an upper bound and a lower bound for our dataset, and then any data point less than the lower bound and higher than the upper bound is considered as an outlier. Now the question is how to specify those lower bound and upper bounds. Upper bound actually is defined as average of data point plus a coefficient of a standard deviation, and lower bound is defined as average of data point minus a coefficient of a standard deviation. Let's consider the figure that I depicted here. In this figure, the blue points actually are data points in our dataset, and the dashed line is the average of these data points that we denoted with mean. And then we can have some upper bounds, which is mean plus 1 times of a standard deviation, mean plus 2 times of a standard deviation, and mean plus 3 times of a standard deviation. Similarly, we can have some lower bounds, which is mean minus 1 times of a standard deviation, mean minus 2 times of a standard deviation, and mean minus 3 times of a standard deviation. In this figure, for instance, I consider mean plus 3 times of a standard deviation as an upper bound, and mean minus 3 times of a standard deviation as a lower bound. So any data point above mean plus 3 times of a standard deviation and below mean minus 3 times of a standard deviation is an outlier. So as you see, this data point is above mean plus 3 times of a standard deviation, and it is an outlier. Please note that depending on how aggressively you want to detect the outliers, you can set the coefficient of a standard deviation. If you want to be less aggressive, you can select 3 as a coefficient of a standard deviation. And if you want to be highly aggressive, you can select 1 as a coefficient of a standard deviation. In this figure, I select 3, and it means I am not so aggressive. But if I select 1, you will see these data point are above mean plus 1 times of a standard deviation, and they are outliers. And this data point is below mean minus 1 times of a standard deviation, and it is an outlier. So as you see, if I select 3 as a coefficient of a standard deviation, I have only 1 outlier. But if I select 1 as a coefficient of a standard deviation, I have 3 outliers. So as you see, I use the mean and the standard deviation of the data points to detect outliers. It should be noted that there are some extensions for this approach. For example, we can have dynamic upper bound or dynamic lower bound, or for the data points that has seasonality pattern, we should define an upper bound and a lower bound that follow the seasonality pattern. And for the data point that has increasing or decreasing pattern, we should define an upper bound or lower bound that follow increasing or decreasing pattern as well. Okay, I already explained you the approach, but in example that I want to provide you here, I want to focus on order quantity in purchase order 23 data frame, and I want to select 1.6 as a coefficient of a standard deviation. I mean any values less than mean minus 1.6 of a standard deviation, and any values greater than mean plus 1.6 of a standard deviation is outlier. So I select 1.6 as a coefficient of a standard deviation. In most of machine learning algorithms, the coefficient of a standard deviation is set as 1.5, 1.6, or 1.7. So in this example, I select 1.6 as a coefficient of a standard deviation. Okay, let's see one example and see how I can apply this approach in our case study. As I explained previously, we can use .min function to find the average of a specific column in a data frame. So by using .min function, I find the average of order quantity in purchase order 23 data frame, and I store the result to order quantity mean variable. So as you see, 550.57 is the average of order quantity. Similarly, I can use .std function to find a standard deviation of order quantity in purchase order 23 data frame. And I store the result to the variable order quantity std_dev. As you see, the standard deviation is 286. And here I define the upper level, which is average of order quantity plus 1.6 of standard deviation of order quantity. And lower level is average of order quantity minus 1.6 of standard deviation of order quantity. So as you see, I use the average that I calculated in this step, and I use the standard deviation that I use it in this step. Now I can use lower bound and upper bound to detect outliers. So in cell 63, I print the records where order quantity is less than lower level. What is the lower level value? I can print it here. So the lower level is 57.34. And as you can see in the last column, all order quantities are less than 57.34. So as you see, all of these values are less than 57.34. Similarly, we can print the records where order quantity is greater than upper level. Let's again print the upper level. So the upper level value is 973.8. And here you can see the records where order quantity is greater than upper level, which is 973.8. You see, order quantity in last column is greater than the upper level. So we need to exclude these records, the records that order quantity is greater than upper level, and records where order quantity is less than lower level. How to eliminate them? It's very easy. So here, by using one filtering, we can exclude those records. I already explained how to apply filtering on a data frame in chapter 2, so please read chapter 2 to understand how I do filtering on order quantity. So here we have two conditions. Condition 1 says all order quantity in purchase order 23 data frame should be greater than or equal to lower level, and condition 2 says order quantity in purchase order 23 data frame should be less than or equal to upper level. And I use AND condition. And I store the result of this condition to a new data frame, and I call purchase order 23 data frame 3. Now in new data frame, I mean purchase order 23 data frame 3, all order quantities are greater than or equal to lower level and less than or equal to upper level. So as you see, I define one upper level and one lower level by using mean and standard deviation, and I eliminate any data point which is above upper level and below the lower level. Now the new data frame, I mean purchase order 23 data frame 3, has meaningful data in order quantity column. So I clean purchase order 23 data frame based on column order quantity. So let's back to our slide and summarize the third type of pollution, which was extreme values. As I explained, by extreme values, I mean outliers, biased data, or anomalies, and they are the data points that have abnormal pattern. I mean their pattern is different from other normal points in a data set. And I already explained how to detect outliers and how to handle them in a data set. Now let's focus on the next type of pollution, which is bad formatting. In this section, I want to explain how to manage different data types in a data frame. Let's again go to our Python script and cover some examples. In the first example, I want to focus on item data frame. And as explained previously, we can use .info function to see data type of each column. I already applied .info function on item data frame. And as you see, column item number is in integer format, item name is in object format, warehouse is in object format, sales code is in object format, and so on. Now the question is whether these columns are in the correct format or not. Again, to answer these questions, we should have a comprehensive knowledge about the data frame. Based on my knowledge on item data frame, I know that item number should be a string, but in this case it is integer. And I know that on hand should be integer, but in this case it is float, and the rest of the columns are in the correct format. So I have two columns which are not well formatted. Now the next question is how to change the data type of item number from integer to float, and how to change the data type of on hand from float to integer. First, I focus on hand column. I mean in item data frame, I first consider on hand column. And here I want to explain how to change the data type of on hand from float to integer. Again, it's very simple. Whenever you want to change the data type of a column from any format to integer, you can use as type in parentheses int function. By using this function, you change the data type of on hand from any format to integer format. I mean, in this part of the code, you change the on hand data type from any format to integer, and then you store it to the on hand column again. There is one important note here. Whenever you want to use as type function in Python, you need to make sure that there is no null values in that column. So before using as type function in Python, you should always fill null values with some quantities. So as you see in the previous step, I fill null values in on hand column with 0, and then in the next step, I change the type of data on hand to the integer format. And here I summarize some important function. As I explained, whenever you want to convert any column from any format to integer, you can use as type in parentheses int function. In the second function, whenever you want to change a column from any type to float, you can use as type in parentheses float function. And in third case and fourth case, you can change the data type of a column from any type to a string by using .apply or .map function. In all of these functions, you need to first fill null values with some meaningful values. If it is integer or float, for example, you can fill null values with 0 or -1 or 1, and then apply those functions. And if it is a string, you can fill null values with a specific string, with a space, or whatever. And as you can see below, if I use .info function again, now on hand inventory is in integer format. Please note that both int32 and int64 are integers, but int32 is for small integer numbers and int64 is for large integer numbers. So let's see another example. In this example, I want to show how to change the format of a decimal number. Again, I focus on item data frame. And in this data frame, I want to focus on column size and column weight. And I want to specify the number of decimals in these two columns. So as you see, I can use round function. In column size, I can put 2, and in column weight, I can put 0. Here, 2 and 0 shows the number of decimals for float columns. So as you see in the resulting data frame, in column size, we see numbers until 2 decimals, and in column weight, we don't see any decimals. If we look at the input data, we have column size with 3 decimals. Now we change them to 2 decimals. And in column weight, we have numbers with 1 decimal, and we get rid of the decimal. And now we see numbers without any decimal. Okay, so let's look at the data frame again. The size are until 2 decimals and weight without any decimal. So it's the way to define the number of decimals in columns with float data type. Okay, let's consider the next example. In the next example, I want to focus on purchase order 2023 data frame. Again, I use .info function to see data type of each column. Again, based on my knowledge, order quantity should be in integer format, but now it is in float format. And in the following, I explain how to change them to integer format. As I explained previously, we can use asType in function, but before using that function, we should fill null values with some integers. In this case, I fill null values with 0, and then I use asType int function. So in this way, I change data type of order quantity from float to integer. I need to mention one important note here. Whenever you have null values in a column with integer format, by using .info function, the data type of that column is shown as float. I mean, if you go to order quantity in input data, in purchase order 2023, you see these order quantities are integers. You see? But since there is some null values in this column, the data type is shown as float. Okay, so whenever you have floats for some integer columns, it does not mean necessarily that that column includes some float numbers. Okay, let's go to our slides and summarize the fourth type of pollution, which was bad formatting. As I explained, first you need to fill or eliminate null values with some meaningful data and then use asType function. As I explained in the first case, you can use asType int to convert the data type to integer. You can use asType float to convert the data type to float, and you can use apply string or map a string to convert the data type to a string. And here I mentioned the important note: if you don't fill or eliminate null values, in most of the case you will receive errors. And finally, I explained the round function, where you can specify the number of decimals for float columns. For example, in column 1, I want to see the float numbers until 3 decimals. In column 2, I want to see float numbers until 1 decimal. In column 3, I don't want to see any decimals. And in column 4, I want to see numbers until 2 decimals. Okay, we can cover the next type of pollution, which is bad formatting. In this type of pollution, I want to explain you how to get rid of some special characters inside of some columns in the data frame. Sometimes you see some special characters like plus, comma, underline, I don't know, slash in some columns. Now I want to explain how to get rid of those special characters. For this purpose, I introduce a new function in Python, which is replacement function. Let's see how we can use replacement function in Python. So here I provide the replacement function definition. As I explained here, we can use replacement function for two purposes. In the first case, we can replace the whole content of the column with another content. And in the second case, we can replace a special component of the column with another component. Let me provide you some example to see how I can use these functions. In the first example, I focus on order quantity in DataFrame df, and I want to replace some quantities with new quantities. In this case, I want to replace 6 with 11, I want to replace 2 with 32, and I want to replace 3 with 67. And it means by applying this function on column order quantity, all records with quantity 6 will be replaced by 11, and all records with quantity 2 will be replaced by 32, and all records by quantity 3 will be replaced by 67. And in the second example, I want to focus on column accepted in DataFrame df, and I want to replace 0 with no and 1 with yes. And it means in all records that contain quantity 0, we replace 0 with no. And in all records with quantity 1, we replace 1 with yes. And in third example, I want to focus on column location in DataFrame df, and I want to replace E with east and replace W with west. And it means all records with value E will be replaced by east, and all records with value W will be replaced by west. So as you see in the first three examples, I replaced the whole content of a column with a new content. And in the last two examples, I want to replace a special component of a column with a new component. For instance, in the fourth example, I focus on order quote in DataFrame df, and if in content of order quote there is a component dot, I want to replace dot with nothing. Please note that when you open one double quotation and immediately close it, it means nothing. But if you open one double quotation and enter a space and close a double quotation, it means a space. So be careful, a space is a character. Okay, dot, slash, underline, question mark, plus, and even one space are characters in Python. But if you open one double quotation and immediately close it, it means nothing. I mean, it is null value. So in order code in DataFrame, in all records, when I see dot inside of the column, I replace dot with nothing. And in the last example, I want to focus on phone number in DataFrame df. And if there are any plus in the phone number, I replace plus with 2 zeros. As you can see, we use replacement function for two purposes. One is to replace the whole content of the column, like first three examples. And the other one is to replace a special component of the column with another component, like last two examples. And another application of replacement function is to replace Boolean values with some other values. For example, suppose that in DataFrame df manufacturer is in Boolean format, and as I explained previously in Python, Booleans are denoted by true and false. One of the application of replacement function is to convert a column with Boolean format to a column with text format. So in this case, if you replace false with no and true with yes, actually you convert the Boolean column to a column with type string, and you replace all false with no and all trues with yes. Please note that in this case, you can replace false value with 0 and true values with 1. So again, you can use replace function. I mean the same syntax as here, but instead of no, you can write here 0, and instead of yes, you can write 1 here. And in that case, the column with Boolean format is converted to the integer format. Please note that if you replace false with no and true with yes, you convert the Boolean column to a string column. But if you replace false with 0 and true with 1, you convert Boolean column to an integer column. So as you see, we can use replacement function for three purposes. Now let's go to our Python script and see some examples. In the first example, I want to focus on supplier's data frame. And as I explained previously, the manufacturer in this data frame is in Boolean format. I mean, if I use .info function for this data frame, you will see manufacturer is in Boolean format. Now, what I'm trying to do is to convert this column from Boolean format to a string form. So as you see, by using replace function, I can replace false value with no and true value with yes. So in supplier's data frame, I focus on manufacturer column, and I replace false with no and true with yes. And I store the result again to the manufacturing column in supplier's data frame. And if I print the supplier's data frame, as you see, the manufacturing column now is in yes and no format. And now if you apply .info function on supplier's data frame, you will see manufacturer will be in a string format. Please note that in replacement function, you can replace true and false with any value. For example, here you can replace false with no and also replace true with maybe y, or you can replace false with 0 and true with 1. Again, please note that when you want to use integer numbers, you don't need any quotation, but if you want to use a string, you should use double quotation. For example, if you replace false with 0 and true with 1 like this, in this case, 0 and 1 are not integers. In this case, if you use 0 and 1 between double quotations, it means you replace false with 0 and replace true with 1, but 0 and 1 are text, are string, not numerical values. Here, yes, I use .info function, and as you see, manufacturer now is in an object format. Let's go to the next example. In the next example, again, I want to use supplier's data frame, and in column phone, I want to replace all plus values with 2 zeros. If you go to supplier's data frame and input data, I mean this tab, you will see phone number start with plus. I don't like plus at the beginning of the phone numbers. I replace them with 2 zeros, and it's the way to do so. And as you see in the new data frame, all phone numbers start with 2 zeros. In the next example, I want to focus on retails data frame. I mean this tab in our input data, retails data frame. And I want to use again replacement function. And in this case, I want to replace all commas in column manager in retailers data frame with nothing. If you look at tab retailers in our Excel input, you will see in manager column, the name and family name are separated by comma. Now I want to get rid of this comma and replace it with nothing. So as you see, again, I use replacement function and I replace comma with nothing. And as you see in the resulting data frame, the column manager, there is no comma, and those commas are replaced with nothing. So I explain you how to use .replacement function in Python, and I provide you 3 applications of this function. Now let's go to the next type of pollution, which is extra spaces. Let's go to our slide. Now I want to address extra spaces as a 6th type of pollution. And in this section, I want to introduce a new function, which is .strip function. Let's again go to our slides. So here I provide you the definition of a strip function. As I explained here, we can use .string function to remove any extra spaces at the beginning and at the end of any string value. Please note that this function doesn't remove spaces in the middle of the string values. Let's see one example again in our Python script. In this example, again, I want to focus on retailers data frame, and I want to focus on manager column. Here I use .unique function to see the unique values in manager column. And as I explained in chapter 2, by using .unique function, you can see all unique values in a column. And as you see in some values, we see some extra space at the beginning or at the end of the string value. For example, here we can see some extra spaces. Here at the beginning of a string, we can see some extra spaces, and also at the end. And in the middle also there is one space. Here we have one space. Here we have one space. Here we have extra space at the beginning of a string. Here we have some space here. And if you go to retailers data frame in our Excel input, you see some spaces here. So if I go to this cell, you will see there is some spaces here. And also at the end, there can be some spaces. Okay, now the question is how to get rid of these spaces at the beginning and at the end of manager names. As I explained, you can easily use .strip function. Here I apply .strip function on retailer data frame and on column manager. And by applying this function, I actually remove all extra spaces at the beginning and at the end of a string value. And again, if I use .unique function on retailer's data frame on column manager, you will see now there is no extra space at the beginning and at the end of a string values. Again, please note that .strip function doesn't eliminate extra spaces in the middle of the string. For example, strip function doesn't eliminate this space, it doesn't eliminate this space, it doesn't eliminate this space, and so on. So it's the way to get rid of any extra spaces at the beginning and at the end of a string values. Let's go to the next type of pollution, which is missing leading zeros. First, I explain you what is leading zeros, and next I explain you how to handle leading zeros in a data frame. And again, I want to introduce new functions, which is rjust and ljust functions. Let's start first with definition of leading zeros. Leading zeros are any zero that come before non-zero digits in a number with a string format. Let's see some examples in our data set. As you see in the retailer's data frame, column retailer number are numbers with a string format. I already explained different data types in chapter 1, and in that chapter I explained that retailer number is in a string format because these numbers are not quantitative values, so they are in a string format. And any number here that starts with 0 contain leading zeros. So in the first case, we have 00817. So first two zeros in this retailer number are called leading zeros. In the second case as well, in the third row, we have two leading zeros. Here we have two leading zeros. Here also two leading zeros. Here we have two leading zeros. And here the same. And here also the same. Let's see another example. If I go to supplier's data frame, we have also supplier's code for each supplier. And these numbers are in a string format. So any supplier code that starts with 0 contains leading zeros. So as you see, the first supplier has two leading zeros. Here we have two leading zeros, two leading zeros, two leading zeros, one leading zero, one leading zeros, one leading zeros, and there's some numbers without any leading zeros. So any zero at the beginning of any number with a string format is called leading zero. And now I want to explain how these leading zeros can cause some problem in data analysis. Let's go to our Python script and see some examples. In the first example, I want to focus on retailers data frame. As you see in input data in retailers data frame, this data frame, the first 5 records contain leading zeros, but when I read this data frame in Python, you will see that the leading zeros are missing. In the first 5 records, there is no leading zeros. In record with index 10, we also lose the leading zero. Here in record with index 13, we also lose the leading zero. Now the question is how to add leading zeros in columns like retailer number where leading zeros are missing. Let's see the first example here. I use .info function on retailer's data frame, and as you see, retailer number is an integer format, but retailer number is not actually a numerical number. It is a number that assigned to a retailer as a retailer number or retailer code. So retailer number should be in a string format. Now in next step, I want to explain how to bring retailer number to a string format and how to add leading zeros to this column. To add leading zeros to a column that contains leading zeros, you need to follow 3 steps. The first step is to convert that column to a string format. The next step is to remove extra spaces at the beginning and at the end of the string. And the third step is to map the correct format of a string number. So as you see in the first step, I use .apply a string function to convert retailer number to a string format. In the second step, I use .strip function to remove any extra spaces at the beginning and at the end of the retailer number. And in the third step, I use rjust function to map the correct format of the string number. Let's see one example in our slide to see how rjust function works. Here I provide you one example. Let's suppose that we have a string number with value 467 Then by using .adjust function, we can add leading zeros if they are missing. And here you can specify the total number of digits in a string number. So here I define 7. As you see, it maps 7 digits to a string number. Since we already have 4, 6, 7 in a string number, 4 leading zeros are added at the beginning of the string number. So as you see, in total, we have 7 digits. We already had 3 digits, and 4 leading zeros are added. Similarly, we can use adjust function, but in adjust function, zeros will be added on the right-hand side of the string number. So as you see here, I explain the 3 steps for adding leading zeros. Again, the first step is to convert the column to a string format. The next step is to remove extra spaces. And the third step is to add in leading zeros by using our adjust function. Now let's go to our example in our Python script. Here I use 5 as a number of digits because I know in retailer number of digits in total is 5. Then by applying this step, we add leading zeros to the column retailer number. Here I already print the data frame, and as you see now, the leading zeros are added. In the first 5 records, leading zeros are added. Leading zeros are added here and also here. And now if we use .info function retailer data frame, you will see now retailer number is in object format. Okay, let's see the next example. In the next example, I want to focus on customer order line 2023. In this data frame, we have also retailer number. So again, retailer number is in a string format and contains leading zero. So again, we can apply these 3 steps to add leading zeros to retailer number. Let's see the next example. In the next example, I want to focus on purchase order 2023, which shows the order we purchased from suppliers. That shows purchase order 2023 on Excel input. I mean this tab in our input data. Now I want to show when we read this data frame, the leading zeros in column supplier code is missing. I already read this data frame and printed here. And as you see, leading zeros in supplier code column are missing. As you see in cell 92, I follow again 2 steps and I add leading zeros to the supplier code. The first step, I convert supplier's code to the string format. In the second step, I remove extra spaces in supplier code column. And in the third step, I map the correct format of the supplier code as a string number. As you see, the correct format of the supplier code is a string number with 6 digits. So here in the third step, we need to map 6 digits here. And if I print the data frame again, you will see now the supplier code contains leading zero. So now supplier code is in the correct format. Okay, let's go to our slide and cover the next type of pollution, which is outdated data. Another name of outdated data is obsolete data or data obsolescence. So whenever you heard about data obsolescence, it means you have a set of records in your data set which are not reliable for any analysis. I mean, they are the records in the data set that already lose the value of the information. So when you are working on a certain analysis, you need to address the time window very carefully. For example, if you want to estimate the price of a certain product for next year, then looking to very old data can lead to some inaccurate prediction. Or for instance, when you want to forecast demand for a certain product, in this case, if you don't look at the old data, you may lose the pattern of the demand and you may come up with inaccurate forecasts. So for some group of products, you may need to review 2 years of history. And for another group of products, you may need to review 1 year or less. So what I'm trying to say is that deciding on time window depends on the nature of your analysis. And you can decide on a proper time window in an analysis based on your experience and knowledge. For some analysis, you may need to look at the data point of 1 week ago. In some analysis, you may need to look at the data point of 2 years ago. And for some analysis, you may need to look at the data points of a couple of days ago. So depending on the nature of your analysis, you need to decide on time window for your data points. Please note that by time window, I mean data recency. And it means how far we should back in time and do our analysis. And as I explained here, by filtering on dates, you can select your time window in your analysis. Again, based on the nature of your analysis, you need to filter on different dates in your data set. For example, if you are doing some analysis related to customer order lines, the customer order date might be a good date to do filtering on. Or for instance, when you want to do some analysis related to freshness of some perishable products, then you need to focus on order date of the products. So whenever you want to do an analysis, you should always think of the time window. Okay, let's focus on the next type of pollution, which is missing data. When you don't have data for certain columns in your data set, we say you have missing data or missing values. Data can be missing due to incomplete data entry, machine malfunction, or many other reasons. So for any data analysis, we focus on some specific columns in a data frame. Before doing any analysis, we need to make sure that values of those columns are not missing. As I explained in the first type of pollution, I mean null values, you see in some columns, some records are missing. And as I explained in that section, you have three options. The first option is to eliminate those records. The next option is to leave them as they are. And the third option is to replace those null values with some meaningful data. Please note that when you replace null values with some meaningful data, we call them imputation. So whenever I say I did imputation in data, I mean I fill null values with some meaningful data. But in the last type of pollution, which is missing data, I mean you miss some records for a specific date or for some specific period of time. For example, if you do some analysis on customer order line and you see the entire customer order lines for a specific date is missing, and it means something went wrong with data entry in your data set. This kind of pollution might be due to malfunction of ERP system and needs to be addressed by IT department. So it is the end of part 1 in chapter 3. As you see in this part, I covered general pollution in a data set. And in the next part, I will talk about data manipulation. And here are the topics that I want to cover in part 2. Please don't forget to subscribe and like my channel. And if you have any question, please write down in comments below. So see you in chapter 3, part 2.